I'm excited to announce that today from Mistral AI and available immediately on Bedrock are two new sets of open weights models. The first is Mistral Large, which is a big leap forward from their Large 2 model, doubling the context window size and vastly increasing the number of model parameters by more than 5 times. We're also launching today Ministral 3, which is a cool set of 3 models that offer really great deployment flexibility for ultra-efficient edge devices or single GPU deployments or advanced local operations. It's going to be super fun to see how you all use all of these open weights models. Now, in addition to providing a huge selection of third-party models on Bedrock, last year we announced Amazon Nova, which is Amazon's family of foundation models, delivering the industry's best price performance for many workloads out there. Over the last year, we've actually extended the Nova family to support more use cases and deliver more possibilities for you that deliver real value. We've unlocked speech-to-speech use cases, as an example, with Amazon Sonic. And just a few weeks ago, we launched the industry's best performing model for creating embeddings across multiple modalities with Nova's multimodal embeddings.
And the challenge probably isn't that you don't have the data you need. The problem is you can't find the data you need. And now you might be thinking, well, creating a vector database might be a great way to find that database. And that's true. But unfortunately, there's a challenge. Existing embedding models are highly specialized to handle certain types of data, images or text. And so if you want to benefit from the wealth of unstructured data you might have, it means you likely have to combine models. But the catch is you can't really combine models because you can't search vectors across different embeddings models because those abstract dimensions that we talked about likely hold entirely different concepts. So this is precisely the challenge that we set out to handle with the new Nova multimodal embeddings model. Now, this is a state-of-the-art embeddings model that supports text, documents, images, video, and audio. And it converts all of these concepts into a shared vector space, creating a unified understanding of your data. And better yet, the Nova multimodal embeddings model does this all with industry-leading precision.
Announcing a new generation of Nova with Nova 2. Nova 2 delivers cost-optimized low-latency models with frontier-level intelligence. The Nova 2 family includes Nova 2 Lite, which is our fast and cost-effective reasoning model suitable for a broad set of workloads, and Nova 2 Pro, which is our most intelligent reasoning model for highly complex workloads. We're also introducing Nova 2 Sonic, which is our next-generation speech-to-speech model that enables real-time, human-like conversational AI for all of your applications. If you wanted a model to try to understand all that was going on in the keynote today, you'd want to get the nuance and understanding of everything that we're saying. That means you'd have to listen to what I'm saying. You'd have to understand the contents of all these slides. You'd have to be able to watch the videos and understand what's going on and what we're showing. Now let's say you want to take that same model and produce a summary output for your sales team, where it had a summary of all the launches we announced today, along with some images and marketing material. Now, if you wanted to do this, you could, right? This is possible today, but it means testing a wide variety of different models, stitching them all together, and trying to accomplish this outcome, which is totally doable, but is quite hard. It'd be easier if you had a single model that could do all of that. And that's why I'm excited to announce Nova 2 Omni. It's a unified model for multimodal reasoning and image generation. Nova 2 Omni is the industry's first reasoning model that supports text, image, video, and audio input, and then supports text and image generation output. So that's 4 new industry-leading models from Amazon Nova, and we're just getting started. What if you could integrate your data at the right time during the training of a frontier model, and then create a proprietary model that was just for you? I think this is actually what customers really want. And so we asked ourselves, why not? And today I'm excited to announce Amazon Nova Forge. Nova Forge is a new service that introduces the concept of open training models. With Nova Forge, you get exclusive access to a variety of Nova training checkpoints, and then you get the ability for you to blend in your own proprietary data together with an Amazon-curated training data set at every stage of the model training. This allows you to produce a model that deeply understands your information, all without forgetting the core information that the thing has been trained on. We call these resulting models novellas. And then we allow you to easily upload your novella and run it in Bedrock.
So we asked ourselves, how can we make this easier? The answer was not just to train a better model. We needed a better model, of course, but that needs to be part of an end-to-end automation service. NovaAct is a new service to build and manage fleets of agents for automating production UI workflows with high reliability, ease of implementation, and fastest time to value at any scale. It achieves 90% reliability in the enterprise workflow settings that it was trained to perform.
One big challenge that we've seen when you're building agents is how do you get them to behave predictably and in line with your intents? What makes agents powerful is this ability to reason and act autonomously. But that also makes it hard for you to have complete confidence that your agents aren't going to stray way out of bounds. This is a little bit like raising a teenager. I currently have 2 awesome teenagers myself at home. Now, as your kids get older, you have to start giving them more autonomy and freedom so that they can learn, or adulting, as they like to call it. But you also want to put some ground rules in place to avoid major issues. Think about when your kids start driving. This is the current situation that I'm in. All of a sudden, the kids have all of this autonomy. There's a ton of things that they can go and do by themselves, but you still kind of want to have those guardrails in place. Like you have to be home by a certain time, or you don't want to drive more than, say, 5 miles an hour over the speed limit, things like that. One way you can actually build trust in agents is by making sure that they have the right permissions to access your tools and your data. Agent Core Identity provides a great way to do this today. But while permissions on your tools that your agents can access is a good start, what you really want to be able to control is the specific actions that your agents can or cannot take with those tools. You have actions like, what is the agent going to do with those tools? How can they use them? Who are the tools for? And today, customers struggle with this. You can embed policies inside directly in your agent's code, but because agents generate and execute their own code on the fly, these safeguards are really best effort and can only provide you weak guarantees, and they're really difficult to audit. In practice, this means today you can't, with certainty, control what your agent does or does not do, while also giving it the agency to go and complete these workflows on its own. As a result, most customers feel that they're blocked from being able to deploy agents to their most valuable, critical use cases. And today, that's why we're announcing Policy in Agent Core. Policy provides you with real-time deterministic controls for how your agents interact with your enterprise tools and your data. Now you can set up these policies that can define which tools and data and agents, which tools that your agents can access, but also how they access them. So whether they're APIs or Lambda functions or MCP servers or popular third-party services like Salesforce or Slack. And you also can then define what actions they can perform and under what conditions. So what Agent Core does is it then evaluates every single agent action against this policy before ever granting access to your tools or your data.
So with policy, you get real-time, deterministic, and auditable controls over how your agents interact with outside tools and data. You can describe in natural language the actions you want to allow, and then we translate them into a formal representation called CEDAR.
But in addition to how agents are performing operationally, there's other things that you actually want to know. You want to know things like, are your agents making the right decisions? Are they using the best tool for the job? Are their answers correct and appropriate? Are they even on brand? These are things that are super hard to measure. Today, it usually actually requires you to have a data scientist. The data scientist is going to build some complex data pipeline. They're going to select a model that's going to try to judge the outputs of their agents. They have to build the infrastructure to serve these evaluations and then manage quotas and throttling. And each time you want to roll out a new agent or you want to upgrade to a new version of a model that you're using, you have to do all of this work all over again. But unlike traditional software, actually testing and pre-prod here, even then, is really hard. You only know how your agents are going to react and respond when you have them out there in the real world. That means you have to continuously monitor and evaluate your agent behavior in real time and then quickly react if you see them doing something that you don't like. We think we can make this a lot better. Today, I'm excited to announce Agent Core Evaluations. Evaluations is a new Agent Core service that helps developers continuously inspect the quality of their agent based on real-world behavior. Evaluations can help you analyze agent behavior for specific criteria, like the ones I mentioned: correctfulness, helpfulness, harmfulness. And they come with 13 pre-built evaluators for common quality dimensions. Of course, you can always create your own custom scoring system with your own preferred prompts and models as well. And you can easily evaluate agents in this testing phase to correct any issues before you end up deploying them broadly. So now, if you're going to upgrade to a newer version of a model, as an example, you run your evaluations to evaluate your agent. And you want to make sure that it maintains the same level of helpfulness, for example, that you have in your current release. You can actually also use evaluations in production to catch any of those hard-to-find quality degradations really quickly.
So what you need is not just the memory of the past, but also the context of the current interaction. That's why we launched episodic memory, a new functionality with Agent Core long-term memory so that agents can remember and learn from the past experiences. This new feature gives the ability to build agents that truly understand user behavior, and they adapt automatically by recognizing patterns across similar situations, and they proactively offer solutions that work. It enables agents to store and recall specific experiences or interactions as discrete episodes, similar to how we remember particular events in our lives. The more your agents experience, the smarter they become.
Now, results like this are why we continue to expand our specializations. And that's why I'm excited that we're launching 3 new agentic AI competency categories: applications, tools, and consulting services. Partners with these specializations meet our high standards for security, reliability, and responsible AI. We're awarding agentic AI competency partners with 50% more marketing development funds and a specialization badge in the AWS Marketplace so customers can find them. With over 100 competencies and specializations today,
It gives you the ability to create custom code transformation agents to modernize any code or API or framework or runtime or language translation, even programming languages or frameworks that are only used by your company. And customers are already flocking to it. We've already seen customers doing Angular to React migrations, converting VBA scripts that are embedded in their Excel sheets into Python, converting Bash shell scripts into Rust.
I am thrilled about the general availability of composability in AWS Transform. With composability, partners can now integrate their own tools, agents, and knowledge bases. They can build customer workflows and deliver all of these seamlessly within AWS Transform. Already, partners like Pega, Capgemini, and Accenture are building integrations using their deep industry and domain knowledge.
We're introducing frontier agents. Frontier agents are a new class of agents that are a step function change more capable than what we have today. We generally think about 3 things that differentiate frontier agents. 1, they're autonomous. You direct them towards a goal, and they figure out how to achieve it. 2, they have to be massively scalable. Of course, individually, they can perform multiple concurrent tasks, but you have to be able to distribute work across multiple instances of each type of agent. And 3, these agents need to be long-running. They may be working for hours, maybe even days, in pursuit of ambitious, sometimes frankly amorphous goals without requiring human intervention or direction. Let me introduce the first frontier agent we'll be launching today, and that is the Kiro Autonomous Agent. The Kiro agent is an agent that transforms how developers and teams build software, vastly increasing your developers' team's capacity to invent. The Kiro Autonomous Agent runs alongside your workflow maintaining context, and automating development tasks so that your team never loses momentum. You simply assign it complex tasks from the backlog, and it independently figures out how to get that work done. Hero can now autonomously tackle a full range of things your developer might need, from delivering new features to triaging bugs, even improving code coverage. And all of this takes place in the background so that your engineers can stay in their flow state, focusing on the big ideas. Hero Autonomous Agent connects with your tools that you already use, like Jira and GitHub and Slack, and it does that to build a shared understanding of your team and your work. And so I'm very excited to announce the launch of the AWS Security Agent. This agent will help you build applications that are secure from the very beginning. AWS Security Agent helps you ship with more confidence. It embeds security expertise upstream and enables you to secure your systems more often. It proactively reviews your design documents, and it also scans your code for vulnerabilities. And since Security Agent integrates directly with your GitHub pull requests, it provides your developers with feedback directly into their workflows. Security Agent also helps with penetration testing. It turns pen testing in from this practice that was slow and an expensive process into something that's an on-demand practice. It allows you to continuously validate your application security posture. And we all know that as systems grow, the surface area of what you're operating grows as well. And that means growing DevOps work. This is something that our own teams inside of Amazon have a ton of experience with. At Amazon, we've always believed that the best way to create a great customer experience is to have developers operate their own code. We've been living DevOps for many years, and what we've learned that, frankly, as your service scales, operations can eat up more and more of your time. We thought this is another area where we could put our expertise in your hands. Introducing the AWS DevOps Agent. This agent is a frontier agent that resolves and proactively prevents incidents, continuously improving your reliability and your performance. The AWS DevOps Agent investigates incidents and identifies operational improvements, just like your experienced DevOps engineers would. It learns from your resources, their relationships, and including things like your existing observability solutions, runbooks, code repositories, and CI/CD pipelines. It then correlates all that telemetry and code and deployment data across all of those sources and allows them to understand relationships between your application resources, including, by the way, applications in multi-cloud and hybrid environments. Let me show you how this can transform incident response. Let's say an incident happens, an alarm goes off. Before your on-call engineer can even check in, AWS DevOps Agent instantly responds.
That's why today we are making reinforcement fine-tuning available in Amazon Bedrock. Reinforcement fine-tuning, RFT, helps customers improve model accuracy without needing deep machine learning expertise or large unsolved label data. Bedrock automates the entire RFT workflow. By making this advanced model customization technique accessible to everyday developers. Here, you can start today with Amazon Nova, and we will be starting support for open model weights really soon. That's why today, I'm thrilled to announce the release of new serverless model customization capabilities in SageMaker AI. With this release, you can customize popular models such as Amazon Nova, Qwen, Llama, DeepSeek, and deploy them directly on Bedrock or SageMaker in just a few steps. Better yet, this comes with 2 experiences, and you can choose the right approach based on your comfort level. A self-guided approach for those who like to be in the driver's seat, and an agentic-driven experience that uses an AI expert for folks who like to turn on autopilot in their cars. What if we could find a way to improve training resiliency and reduce ground time? That's why today we are announcing checkpointless training on SageMaker Hyperpod. With this new feature, we significantly reduce the recovery overhead, since the process no longer requires rolling back a partial training, no more than a partial training step. This is a paradigm shift in model training that automatically recovers from infra faults in minutes with zero manual intervention, even with clusters that span hundreds of thousands of AI accelerators. The way we achieve this is by continuously preserving the model state across the distributed cluster. So when something goes wrong, there is no need to panic and roll back to some old checkpoint. Instead, it smoothly swaps out the faulty hardware and uses peer-to-peer transfer to grab the exact model state from healthy accelerators nearby. So now you get faster recovery and significant cost savings in your model training.
The AWS heroes. Yeah, we now have 200. Yeah, they deserve an applause. Oh, there. So I've met community builders, I've met AWS heroes, and these are people that are solving hard problems in their own corners of their world. There are now 265 heroes across 58 countries. But what constantly amazes me is how much we can learn from them. By the way, this year's Now Go Build Award
I have 25 exciting new product launches across our core AWS services to unveil, and I'm going to give myself just 10 minutes to do it. To keep me honest here, the team is rolling out a shot clock, and you all can keep track. Okay. All right. All right. All right. Buckle up, everybody. Let's get to it. Lambda works great when you want to execute code quickly, but sometimes you have a use case where your Lambda function needs to wait for a response, like waiting on an agent that's working in the background for several hours or maybe even long-running workloads with built-in error handling and automatic recovery.
What is serverless? Is it no servers? Is it no operations? Is it don't make me think about the infrastructure? Is it just run my code? Well, customers were telling us something clear. We love Lambda because we don't have to manage infrastructure. But we want control over the performance. And we do want access to the hardware that we need. And so we asked ourselves another bold question. Could we preserve everything that customers love about serverless, the simplicity, the automatic scaling, the operational model, while giving them the performance choice of EC2? And this week, we're thrilled to answer that question with Lambda Managed Instances. Lambda Managed Instances elegantly bridges a gap between serverless simplicity and infrastructure control. With Managed Instances, your Lambda functions run on EC2 instances inside your account, and Lambda manages the provisioning, patching, availability, and scaling. You choose the instance type, you choose the hardware, Lambda handles the rest. It's the next evolution of serverless compute. And the best part, your existing Lambda functions continue to work as is. No re-architecture, no code changes, and no operational burden.
I mentioned earlier that S3 stores more than 500 trillion objects, hundreds of exabytes of data. That is a lot of data. When we launched S3 in 2006, we had a 5 gigabyte max object size. Then, a couple years later, we increased that to be 5 terabytes, and that has been sufficiently large for the past decade. But data has gotten a lot bigger in the past couple of years. So we asked ourselves, what would be the object size that would meet all of your needs today? Should we double it? Triple it? How about 10x it? I'm pleased today to announce that we're increasing the maximum object size in S3 by 10x to 50 terabytes. As the volumes of table data has started to quickly rise, you all have asked for ways that we can help you save money. So today we're announcing intelligent tiering for S3 tables. This can save you up to 80% on storage costs for the data in your S3 table buckets automatically. You also asked us to make it easier to replicate these tables between regions so that you can get consistent query performance from anywhere. Earlier this year, we announced a preview of S3 Vectors, which is the first cloud object store with native support to store and query vectors. And today, I'm happy to announce the general availability of S3 Vectors. You can now store trillions of vectors in a single S3 bucket and reduce the cost of storing and querying them by 90%.
What would it mean if we brought the power of vector search to our largest data service? And with S3 Vectors, we brought the cost structure and scale of S3 to vector storage. And this actually did surprise a few people, even those that know vectors quite well, because this isn't easy. What's great is you can create a vector index the exact same way you can create an S3 bucket. And this enables you to build vector databases of any size with the simplicity of storing data in S3. No provisioning, works at any scale, you pay for only what you use. It's that simple.
That is what accessibility means to us. Not just APIs, but infrastructure on AWS that makes video intelligence viable at any scale. Our partnership with S3 enables us to deliver an incredibly efficient product offering directly to our customers' infrastructure. Now, given the scale of the data we handle, that has a meaningful impact on our customers' unit economics, which unlocks new possibilities.
But I know that many of you out there are still supporting some legacy SQL Server and Oracle databases. There's one last thing that I think all of you are going to love. Several years ago, we launched compute savings plans as a way to simplify making commitments across our entire set of compute offerings. And since that day, I've regularly been asked, when can I get a unified savings plan for databases? And here it is. Starting today, we're launching database savings plans. These can save you up to 35% across all your usage for our database services. All right, boom, did it. A whole second keynote worth of new capabilities for all of you in under 10 minutes. Now you have 4 full days to go out and learn, dive deep into the details, and start inventing. Thank you all for coming to reInvent. Enjoy.
I hope that seeing these new tools has given you some great ideas on what you will create. For me, the hardware improvements with Trainium 4 and Graviton 5, they're going to dramatically accelerate my own projects. While the migration, the modernization improvements with Transform Custom Agents, they're going to make moving off of legacy systems so much easier. And Kiro, the spec-driven development changes the focus for me away from how can I build this to what do I want to build and why not see what happens. We are so excited to see you ask, why not, for your next big idea. As you continue on with today's conference, we've got 4 curated tracks for you with 4 different levels of depth. Watch our quick preview trailers on the homepage and then choose your track. These sessions are built for you to learn more about our biggest launches and technical deep dives. You'll even have the chance to chat with subject matter experts as you watch. And we have a curated list of resources to help you keep learning with opportunities to get hands-on, dive deep into these new tools. So have an amazing day here with us, and I look forward to seeing what you build next.
After performance, the real challenge is scale. Sales Assist in production means thousands of concurrent agents, each making multiple tool calls, running long workflows, and handling sensitive customer data at the same time. So you need a secure, resilient, and elastic runtime that can scale up during peak workloads, scale down when idle, keep each agent session isolated, maintain state during long-running multi-step reasoning workflows, and quickly recover from failures like API timeouts or service disruptions when it's calling multiple different tools and services. Then comes security. Agents act on behalf of humans, so every action must respect fine-grained identity and access controls. If Sarah in Enterprises is using Sales Assist, it should see a list of her Fortune 500 accounts. But when Tom in Startup does it, he shouldn't. The Sales Assist shouldn't see the enterprise accounts. That's per user identity, not shared credentials. And doing that securely across thousands of agent sessions requires deliberate design. Finally, you need visibility and guardrails to know what each agent is doing and to control unsafe actions before they happen. If a deal goes sideways, can you audit what data Sales Assist accessed, what email it sent, what pricing it suggested? Additionally, you need a way to enforce your business rules in real time. For example, never share unannounced features, never discount over 20%. So governance isn't something that you bolt on later. It has to be built in your application from day one. And doing all of these things essentially means building a distributed enterprise scale system that can handle thousands of concurrent sessions, millions of tool calls, adhere to strict latency and reliability requirements, all while leaving very little room for error. And that's the difference between a prototype and a production system. And right now, developers have to do significant undifferentiated heavy lifting in building all of these pieces for a combination of a framework, model, and a set of tools. And as your business case evolves and you want to leverage newer models, newer frameworks, and newer tools, you start all over again. And that is what's slowing down organizations right now in realizing their agentic vision. To address these challenges, we launched Amazon Bedrock Agent Core. It's a generally available service. We launched it earlier this year. It's an agentic platform that provides a complete set of services purpose-built to build, deploy, and operate highly performant agents securely and at scale. Let's look into some of the key characteristics of Agent Core. First, Agent Core helps you optimize time to value because you don't have to manage any infrastructure. All Agent Core services are completely serverless, and you pay for what you use. For example, if you're using Agent Core runtime, you only pay for the active compute and memory that your agent consumes. In fact, you don't even have to pay for the I/O wait time, which is the time your agent spends waiting to get responses back from LLMs and different tool calls. And in most of the agentic session, I/O wait could make it up to 60 to 70% of the overall agent session time. Secondly, Agent Core was built with flexibility in mind. Each Agent Core service is completely modular, so you can use them together or you can use them independently. And each Agent Core service works with any framework or any model out there. So if you built your agent using LangGraph or Cloud Agent SDK, or if your agent is using OpenAI models or Gemini models, you can still use any of the Agent Core primitives with your agent. And finally, Agent Core provides the controls, the access management, and the observability, which are crucial for enterprise deployments. So overall, with Agent Core, you can accelerate prototypes into production with the scale, reliability, and security, which are critical to real-world deployments, eliminating months of infrastructure work. Now let's look into some of the key services that Agent Core offers. First, to build highly performant agents, Agent Core offers memory that helps developers build context-aware agents. It automatically extracts and stores short-term memory across multi-turn user interactions, as well as long-term memory patterns such as semantic memory and user preferences across longer horizon and multiple sessions. Gateway enables you to compose your tools and agents across your ecosystem into a single MCP server interface that you can then expose to your agent remotely. With Gateway, you can combine different tool sources from your REST APIs to your Lambda functions to your existing MCP servers into one unified interface without managing multiple tool connections or implementing any integrations. Agent Core also provides fully managed tools that are essential to most agentic workflows. Code Interpreter enables agents to securely generate and execute code in isolated environments. And Browser enables agents to interact with web applications at scale. Then to deploy and scale agents, Agent Core provides a secure and serverless runtime that is purpose-built to host agents as well as tools. And agents and tools could be built using any framework, any protocol, whether it's MCP or A2A or any model. Agent Core Identity simplifies agent identity and access management, allowing agents to securely access AWS services and third-party services on behalf of users with pre-authorized consent. And we also launched Policy today. This was announced in Matt's keynote, which provides you real-time deterministic controls over how agents interact with your enterprise tools and data. And you can define these policies in natural language. For example, block all reimbursement requests which are over $1,000. And these policies are evaluated and enforced in real time in milliseconds so that every agent action is operating within the boundaries of policies that you have specified. And finally, to operate trustworthy agent, we have observability that provides rich visualization into each step of the agent workflow, as well as operational metrics like token count latency via unified dashboards. It also emits the data like logs, metrics, and traces in open telemetry compatible format, so you can plug it into the monitoring tool of your choice, such as CloudWatch, Datadog, LangFuse, or Langsmith. And we also launched Evaluations today, which is a new Agent Core service that helps developers continuously inspect the quality of agent behavior so that you can catch issues before they cause widespread customer impact. Overall, with Agent Core, you get everything you need to take your agents from prototype to production, built on the AWS foundation that customers already trust. Now, I'm going to hand it over to Mark to go a layer deeper into these services and show you a few demos of how they work together.
Thank you, Vivek. Great introduction to Agent Core, and super excited to be here for my 8th reInvent. My name is Mark Roy. I'm with, did we go to the wrong slide here? Sorry, I might have hit the wrong button. My name is Mark Roy. I'm with AWS, and I'm a global tech lead for Agentic AI. And although you may think I'm only 29 years old, I've actually been building for about 30 years now. So Vivek talked a lot about the chasm of production readiness. I really love that term. I'm wondering who here, after that description, feels like they're in that chasm of production readiness already? Anyone out there? Okay, not too many hands, but let me tell you, it is real. For the last 2 years, I've been working with hundreds of customers trying to build and deploy agents and get real business value, and I see 3 things showing up every time. 1, great-looking prototypes, amazing capability, looks great. Compelling business value that everyone's excited about, all the potential, and then months and usually quarters of heavy lifting and pain and suffering in between. So for the next 15 minutes, I'll drill down into what are those real challenges, and I'll go one level deeper in Agent Core and explain how these services help you solve those compelling challenges. So with that, we've got a lot to cover, so buckle up and let's jump in. Let me start with the very most common and compelling challenge, and that is, where am I going to run my agent? I can't run my agent on my laptop and just share that out to users. So you're an agent builder and you're thinking this through. You've got pressure to deliver some real value here. You know that your agent is going to be used by 10,000 users. You need to ship it now. You've got a security officer breathing down your neck saying you've got to make sure this thing isn't going to do the wrong things. And for most of you, you probably have got a platform team you're working with as well. And they're thinking beyond your one agent. They're dealing with multiple different teams And guess what? You're using LangGraph. There's some other teams using CrewAI, other teams using OpenAI, and it's a bit of a mess. And guess what? If you look at across these business units, they've got 1,000 use cases lined up. So you've got a big dilemma here. How am I going to do this at scale and securely and not spend the next year getting ready? So that's where Agent Core Runtime steps in and gives you the first major component of your platform. Runtime lets you use any framework, any model, host your agent securely and at scale. You can scale from 0 to thousands of concurrent sessions. It comes built in with the ability to host MCP, to use A2A for agent interoperability, OTel for observability, OAuth for security. All of these things help get you that time to value where you can focus on building agents and not building infrastructure. Another key point here is that although you're probably working on, let's say, an intelligent chat experience, that's kind of usually the first step, there's a lot more out there. There's voice agents. There's long-running deep research. There's large payloads to worry about. This complicates what am I going to do about hosting. It's not as simple as just popping it into a Lambda. That sales assistant that Vivek talked about, let's say it's a multi-agent system. You've got one agent running with Claude SDK using Claude models, another one using LangGraph and GPT models, maybe a third one using CrewAI and Gemini, with Strands agent on top of it doing orchestration using Bedrock models. All of this can be done out of the box with runtime, and literally it's just 4 lines of code to take an existing agent and make it ready for Agent Core Runtime. And then you can deploy it to the cloud, and it's ready to scale, and it's ready to be secure. A2A built in, no problem. You've got full interoperability there. And if you want to host MCP servers, you can pop your tools into Agent Core Runtime as well. So I talked about security. I'm not a security expert. I'm kind of glad about that on some days. When you're building agents, you're using agents because you want them to be a little bit more autonomous. You're not wanting to build a hard-coded traditional application. Now, what about when you're dealing with sensitive information? That's my social security number there. Don't grab it, please. You might be giving out credit scores. You're doing very sensitive transactions. And while your agent's being used by one user, there might be another user doing something similar with also sensitive data. So I've got a question for you. Who here, raise your hands high, is ready to stand with their security officer and say they're 100% sure that those conversations are secure? We've got one guy in the front row. I want to talk to you. This is a huge challenge. This, for me as a builder, this is where I wake up with a cold sweat. How am I going to deal with this? Agent Core Runtime does this out of the box. Secure session isolation for no coding involved. It's just there. Safely execute those conversations. There's no risk of leaving temporary files lying around, no risk of getting permission escalations, all taken care of for you. You get multiple concurrent sessions, no problem. When the sessions are done, poof, they're gone. This is using our micro VM architecture, so it's not just a container-level isolation. It's literally a micro VM that ensures that this is going to work, and it does so at scale and with low latency. This is something that I wouldn't recommend trying to build on your own. Okay, problem number 1, let's put a checkbox on that. I think hosting, Agent Core has a pretty good story there. What's the second biggest problem? In my mind, agents, what separates maybe a toy agent from closer to a real-world agent, real business value, is it able to learn? Is it able to remember? Is it able to improve? How do you make that happen? So, first of all, your agent better remember what's been discussed over the last few minutes of a conversation, and then ideally it's remembering what happened in the last few months as well. So that's called memory for an agent. And it better work reliably, so even if the agent needs to be restarted, you better still have that there, and it better be secure as well. And yes, you could build this on your own, do-it-yourself memory. A lot of people out here have probably tried it. Wouldn't necessarily recommend it, but with Agent Core, you get a memory component out of the box. So what does that mean? Pick your favorite framework again, and just plug in Agent Core memory. When you've got that, your events, your conversations feed right into short-term memory. It's got low latency, it's got security, it's there for you to have good conversations. More exciting than that is automatic memory extraction into long-term memory. What does that mean? All of these conversations get fed into a process that runs behind the scenes and extracts knowledge. It extracts facts. It summarizes conversations. It even identifies episodes as of yesterday. We've got episodic memory now built in. And it will actually look across episodes and reflect and get insights. All of these get put into what's called long-term memory. And this long-term memory can be easily plugged into your agent. So now, instead of your agent having this long list of conversations that it's trying to take advantage of, you can selectively pull out long-term memory, manage your context, and make your agent learning from the past. And that's hyper-personalization, and that's, again, making really a real-world experience for your customers, and doing so fully managed, serverless, secure, and plugging into any framework. Okay, so 2 checkboxes. We've got memory, we've got runtime. What's the next big challenge? To me, an agent is pretty useless unless it can take action. You've heard Matt Garman and Andy Jassy say, data is your differentiator. And really, that's true. You could just use an off-the-shelf LLM and get generic answers. That's not going to take you too far. Your agent needs your data, your APIs, your services, and it needs your APIs to take action as well. That's the power. So why is that so difficult? Well, we've got cool things like Model Context Protocol that showed up late last year and is now used everywhere. But how do you put those MCP servers together? And how do you integrate with all of your existing capabilities? That's a lot of heavy lifting. That's a lot of time, a lot of wrapping. And how do you make that secure as well? All of these things add up to a lot of work. So how does Agent Core help? We've got something called Gateway that automatically lets you map those existing resources and surface them as agent-ready tools. So it exposes those APIs as MCP, and those MCP tools plug into Strands and Crew AI, LangGraph, whatever you're using, securely. Let's look at it a little bit more closely here. So Gateway, you can create as many of these gateways as you'd like. When you create a gateway, you can then add targets to that gateway. So I'll add a bunch of API endpoints in there, maybe throw in a few Lambdas, get a couple of existing MCP servers that have been built, or maybe third-party ones. And now you've got a gateway, and you can hand that gateway to an agent builder and say, these are your tools. Or you could have multiple of them. They can discover different gateways. But basically, now you've got agent-ready tools securely at scale to plug into your agents. Massive boost in time to value here. Last cool thing on Gateway. So you started with maybe a lack of tools. You can easily get into a situation where you've got too many tools. Hard to believe, but pretty quickly you can see hundreds or maybe thousands of tools. And guess what happens if you give 1,000 tools worth of MCP metadata to your agent? You don't want to know. It's not very pretty. We have a built-in search, so instead of handing all 300 tools in this case, we give you a built-in semantic search. So as you add tools, they're automatically indexed. You can call this MCP search capability, Now you can do dynamic tool selection. Instead of doing 300 tools, give a handful of tools that are built for that context. Now you've got faster, cheaper, and more accurate. It's pretty rare to get a triple play here, but faster, cheaper, and more accurate, all from doing semantic search. Okay, there's more. So today, in the keynote from Matt, as Vivek mentioned, we introduced policy for Agent Core Gateway. What's the big deal here? So you can give permission for who can access the gateway, who can access tools, and you can have requested tool calls and then which ones are allowed. But what you really want is something a little bit more granular, because what's happening here is your agent has more autonomy, and you're balancing the need for that innovation with the need for control. You don't want to risk getting on the front page of the Wall Street Journal with an agent doing a $100 million mistake. So you want to not trust your agents to do the right thing. You don't want to trust your developers to code up the right controls. So with policy, you're able to intercept every single tool call and apply policies that your administrators can put in place and attach to these gateways. It applies those policies on the fly with low latency, and it does so in a way where you can define these policies in natural language, and they're verifiably correct, verifiably enforced. And it's deterministic. So although your agent is non-deterministic, which is a good thing, enforcing policies needs to be deterministic, and that's what these policies end up doing for you. Of course, we've got observability because you want to know which policies were enforced, why they were enforced, why do they get denied, why do they get allowed, and be able to audit that. And then I clicked one too many times. So this is keeping your agents in their lane, keeping them in bounds, while still allowing innovation. Okay. Great. We've got a couple of built-in tools as well. So beyond just using gateways to get access to your MCP tools, what about the power of LLMs to generate great code? Why not be able to plug that into any agent and make it an instant data analyst? So here I'm saying, in that Sales Assist app, how are my accounts doing? So it can go grab some data, but are LLMs good at analyzing large amounts of data? Not necessarily. They're a lot better at generating code, and now you've got a secure sandbox that you just plug in as a tool, and your agent says, okay, I know where to run this, and you've got great results. You can generate visualizations, whatever you need, actually, that the agent can generate on its own. Secondly, although I mentioned earlier a lot of nice APIs, data sources, who here has a few legacy applications? Maybe they're built 5 years ago, maybe 25 years ago. They're still running mission-critical processes. So we're not going to reinvent those in order to build an agent. Why not use a browser and automate access to those? LLMs are great now at interpreting screenshots, and then you can have your agent click at a certain field, navigate to a different screen, scroll down, scroll up, copy the data into another field. All of this is possible. We give you a headless browser. You just plug it in as a tool, and you're off and running. Okay. Now let's quickly cover 3 cross-cutting concerns. First one is security. It's all well and good to come up with a great agent, but there's table stakes here. It's got to be secure. And this is a challenging problem. User talking to an app, talking to an agent, talking to another agent, talking to tools that are internal and third-party tools. You better get that right. You can't afford to let the wrong user get access to the wrong data or take the wrong actions. So this is pretty difficult. And Agent Core, built into runtime and gateway, takes care of inbound and outbound auth. On the inbound side, you use whatever identity provider you'd like. Maybe it's Microsoft Entra, maybe it's Ping or Okta or Auth0. Plug that in, and we take care of who is the user and are they allowed to use this agent? On the outbound side, we can say, is this user allowed to, using this agent, get access to these tools? And we plug in again on this side with your credential providers. You need Salesforce data, you want ServiceNow or Workday, Jira, whatever it is, there's either an API key or an OAuth credentials, maybe IAM in some cases. We automatically let you configure those as outbound providers, and then we make sure that there's secure access end-to-end on behalf of a user or on behalf of an agent autonomously. This is super important, and please don't try to do this one at home. Don't try to do this one yourself. It's scary, complicated under the hood. I've tried to make it look pretty easy right here. Another table stakes piece of the puzzle is observability. Never trust your agents. Never put an agent into production without being able to know exactly what it's doing. You've got to be able to go back and find out exactly what it did. Here's the request. Here's the plan it put together. Here's the steps that it took. Maybe it redirected and tried something else. This is the inputs that it passed to the tool. This is what it got back. Maybe it got back an error and it retried. You need every bit of that. Auditors are going to come in. Legal's going to come in. Why did this agent do this? You've got to be able to have full observability. We've got that across all of these services. We also give you dashboards so you can easily see not only typical metrics like latency, error rates, and so forth. You can see the end-to-end visualization, a hierarchical timeline, the full trajectory, the inputs, the outputs, it's all there. And in case you were wondering, yes, we have open telemetry. So if you want to use Dynatrace or Datadog or LangFuse, anything that you'd like, go for it. Okay, last, cross-cutting concern, arguably the most important one so far, drum roll please. How do you know how good your agents are? You've got to be able to measure, are they doing the right thing? Right? So this includes, are they being safe? Are they being responsible? Are they being polite? Do they have the right tone? Are they giving back the right answers? Are they making the right tool calls? Are they passing the right parameters? If you don't know the answers to these, you're not doing a good enough job for mission-critical agents in production. So in today's keynote, we introduced agent core evaluations. So what does that do? So in under a minute, you can go to the console, pick your agent, pick a set of metrics that you want to turn on, say where your traces are coming from, turn on a sampling rate, and then say go. Any traffic that shows up in that agent is going to get automatically evaluated. So agent core evaluations will evaluate each of those metrics on those traces and give you scores. And not only will it give you a number or a label, but it will say why. So why did it decide that that was the score? You'll see the reasoning, and that's all logged. You'll get dashboards, and you can even do on-demand evaluations. So this is huge, critical, and it was launched today in public preview in Agent Core. So this is the entire Agent Core platform. It'll probably get bigger and better over time, but this is where it stands today. And as Vivek mentioned, you can pick and choose here. These are composable services. Decide which ones you're having challenges with, kick the tires on that, integrate what you need, use any framework, any model, OAuth, OTel, A2A, MCP, all of the right acronyms are there. So let's see a quick demo here, and then I'll bring you Sabarshis from Ericsson to dive in even further. So here's the scenario. I've said any framework, any model, and I've said A2A, but if you're not sure, if you really believe that that's true, let's see it in action. So in this example, I've got an orchestrator using Google ADK and Gemini. You can see a couple of sub-agents, one using Strands and Bedrock models, another one using OpenAI and GPT-4. And they're communicating using A2A. Are you going to boot me off the stage, Parshas? Am I running too far? Okay. I'll be done in about 2 minutes. So we're using A2A. We're using Agent Core Gateway to access tools. We've got memory and observability. And let's keep going here. Here's the UI. We've got a JavaScript UI. On the left, we're showing you access to A2A agent cards. I'm handing it a task. I'm asking it a question. It's actually delegating that to one of the sub-agents that's using a different framework, different model, uses A2A to get there. It comes back with an answer. I'll scroll ahead here. Too far, sorry. I don't like this laptop. Let's see. Oh man, this is great. My apologies. Okay, it's not going to cooperate with me. So we're using A2A to have a conversation. It's using multiple of those servers. This is, at the end here, we're showing Agent Core memory as well. So we're browsing, we're showing you the short-term memory, the detailed conversations were tracked, showing you the long-term memory where it learned some facts and was able to surface those. So with that, let me hand it off to Sabarshis from Ericsson to talk about Agent Core.
Thank you, Mark. Hello, everyone. You just heard about Agent Core and how it bridges the gap between proof of concept to production. Now, I'm going to show you how this looks like in practice. My name is Sarvashish Das. I am a principal data scientist and tech lead at Ericsson. Within Ericsson, we are building a number of agentic solutions across different areas. And today, I'm going to show you one of our agentic solutions that reduces our network engineers' research time from days to minutes. Before that, let me give you some context about Ericsson. If you think about global connectivity, Ericsson is at the heart of it. Right now, as I speak to you, 50% of the 5G traffic throughout the world passes through the technology that we build. With such a scale, it comes complexities. The question is that how do we keep our network engineer efficient in such a complex environment? In reality, our network engineers were trapped in knowledge silos. Let me explain. A network engineer working on a feature need to look into thousands of different documents just to get to understand what this feature is all about. And then they need to find out what exactly this has been implemented in our millions of lines of code base that is distributed on hundreds of different subsystems. You can imagine this takes days. Not because the work is hard, but the information is fragmented. The knowledge is isolated. I can imagine that many of you have also seen this in your organization. Our goal here is to fuse the information across the different knowledge silos to make a unified understanding of the system. How to do that? Here is our solution. We have created a 3-layered architecture to eliminate the knowledge silos. As you can see, at the bottom layers, we have industry standards, we have our code base, we have product information. These are all fragmented information. We need to process this document in a way that it is ready to consume to the next layer, the knowledge layer. That's why we have developed advanced data processing pipeline. In the advanced data processing pipeline, we fetch the data across different knowledge silos, pass through Gen AI pre-processing pipeline. The goal for the Gen AI pre-processing pipeline is to fetch is to process the data, clean the data, and also the key is to extract information from different modalities. Once it is done, it stores the data to different AWS storage, depending on what data type. It can be AWS Bedrock knowledge base, or it can be a graph database. Once the data is ready, it fed to the next layer called knowledge layer. These knowledge layers consist of three components, as you can see. We have specialized agents. These are agents that are experts you can think about in different areas. So we are running a number of this type of specialized agents. Second, we have specialized model. These models are specialized in a sense that we have trained those models with our in-house data and also the code base. And the next part are the developers' tools. These are the tools our network engineers uses on a daily basis. The knowledge layer is connected on the top with an orchestration layer where the agentic orchestration takes place and communicate to the knowledge layer using MCP protocol. The key here, we are not just connecting different tools in this layer architecture. Instead, we are enabling system comprehension, the system that understands the whole workflow of our network engineer. Let me show you how these systems looks like when you deploy this on production using agent code. So this is our architecture that is deployed on agent code. Our network engineer interact with the system using natural language, just like asking a question to your colleague. There is very commonly one question people are asking that, what is a HARC timer? Any of you have any knowledge about HARC timer? Could you raise your hand? I can imagine that this is a very specific, telecom-specific query questions. So then the next step is the Amazon Q developers or the front end. These are the agentic system that basically interprets the queries and try to identify what specialized knowledge needed to answer this question. And based on that, it requests securely through the gateway to different specialized agents that are deployed on agent code runtime. Agent code runtime gives us the flexibility to deploy any framework, any open source framework on this. And these are serverless. So in this example, you can see that we have 3 GPP agent, which is an expert in telecom standards. We have code generation agent. This is an agent that helps our network engineer to generate code. This agent specially powered by in-house trained LLM. Ericsson builds its own ASICs, and the architecture is just a proprietary information. Off-the-shelf coding models that is available today is not aware of those information. And then another example, you can see the RAN system design agent, which is an expert in designing the system and as well as how we are configuring within Ericsson context. All these agents sits on a strong knowledge foundation, as you can see on the bottom part in the knowledge layer, and that has been created using advanced data processing. The key here that all these agents that you can see running on these agent code runtimes, they do not work in isolation. Instead, they collaborate with each other, they share the context, and they build their insight based on each other's finding. We are also leveraging other agent code services that makes this architecture enterprise ready. For example, agent code observability gives us the flexibility to check at a granular level how our specialized agents behave and why. The identity also gives us a secure way to give access control. Now the question is that how our network engineers uses this system. So you can see that generally, as I mentioned, they interact it with natural language. So this is an example question. Explain how HARC timer works and elaborate in downlink design. Identify and list the main implementation component in the code. As you can see, this has multiple parts asking about HARC timers and also implementation in the code. As you can imagine that a typical RAG solution is not going to give you the answer that our network engineer is asking for. In our case, with our agentic solution, first the RAN system design agent kicked in, and it is a deep research agent. What it does is it looked for hundreds of different documents, try to identify what is this hard timer, and generate a deep research output. And this deep research output then fed to the next agent is our AI code search. AI code search able to find out from natural language where exactly it has been implemented by looking at our millions of lines of code base. Once it is done, it passes on the output to the next Ericsson Silicon LLM. And this is also another in-house trained LLM capable of explaining the code. As you can see, all these agents is not going to work in isolation, but they collaborate and share the context. At the end, the network engineer will not just get a chatbot response. Instead, a system-level understanding from the theory to the architecture to the implementation in the code, and all connected, how the features works. Let me show you quickly two examples of the output. So this is an output generated from our deep research agent. As you can see that it's a very comprehensive documentation, and also it generates the images on the fly. That helps our network engineer to understand the concept easily. This is another one where our Ericsson Silicon LLM explained the code, and you can see that it's not explaining just a syntactical explanation. Instead, it's try to connect it with the concept. Now imagine a network engineer started working on these features, have to do all these things manually, looking at the features like a deep research on that, finding the implementation in the code base, and connect. And this takes, depending on their experience, 3 to 5 days. Using our solution deployed on agent core, we can get it in less than 7 minutes. This is a 99% reduction in the research time for our network engineer. We have built the system. The next question that how do we evaluate this system? For evaluation, we are using a dual approach. First of all, using an automated script or framework, we can easily identify the consistency and correctness, but it's also important to evaluate through human expert for the accuracy and whether it meets our network engineer expectations or not. By combining the human feedback that we have received and also the value, it gives us the confidence on the reliability of the system. While building this agentic solution, there are a lot of learnings for us, and let me share the important ones. It's a perfect timing, we say, for agent core. We have been building this type of specialized agent for some time, and we reached to a point where scalability was an issue for us. When we see agent core, it feels like it's exactly what we needed. Next is that involve the domain expert early. What I mean is that if you are developing an agentic solution, my recommendation, you involve your domain expert from the day one. For us, the feedback that we receive from the domain expert about how our network engineer works, what are their behaviors, and what are their pain points, help us to design these specialized agents. Third is important of unifying the knowledge. When you connect your data and make a unified knowledge base from industry standards, code base, your product documentation, you get a system-level understanding, and that overall improve the accuracy of the answers that we get, and also at the same time, it's remove any ambiguities. Last but not the least, infrastructure matters even more than we think of. Using agent core, our network engineers focus more on developing the agentic structures and as well as how the agent will behave. All the heavy lifting is done by the agent core. As a result, the development life cycles improved significantly. let me summarize here. With Agent Core, we have moved beyond just answering questions. We have developed a system that understands how our network engineers work and think. And we are excited what comes next. With that, let me close here with a perspective from our organization head, Doug Linbo. By unifying the data and the information, Agent Core let us build specialized agents that scaled over our tens of thousands of network engineers. Thank you. Over to you, Mark.
Thanks, Subharshish. Okay, since I was so great at Demo 1, I'll do a quick pass on Demo 2 here. I'm just going to kick it off and not try to click any mouse. What this is trying to show here is I get a lot of questions about how well, if I'm using a coding assistant, am I able to easily use Agent Core? And yes, what this is showing you is a scenario where I've got an existing REST API. I've got a URL to it and an API key. And I kicked off a session with Kiro to say, take that existing API, give me a gateway that will use that via MCP, give me a strands agent to use that, and then deploy that agent to the cloud, write a client, test that client, and even write a load test for me and run that. So here it goes. So I gave it some context, I gave it the URL, I gave it the API key. Now it's exploring the Agent Core command line to understand what's offered. It figures out, oh, I can do this. I can create a gateway. I see how to do that. I know I've got access to the API. So it probes that REST interface, extracts the open API spec. Earlier you saw the Swagger user interface there describing the API. It's able to download that. It pops it into a JSON file, uploads that to S3, and now it's ready to create the gateway. So it creates the gateway, and here on the left I'm showing you the actual API spec. It was able to retrieve that on the fly. And again, I still haven't written any lines of code. I haven't touched any command lines at all. I just said, hey, go do this for me, please. And the gateway's already created. Here we're just waiting for the DNS propagation to complete. It takes about a minute. So it's got it all set up. It's got it configured. In about another 10 seconds here, it'll be ready. Once it's ready, then it's going to add the API target to the gateway. So what is that all about? It's got to configure an OAuth authorizer. In this case, I've told it we should use Cognito. That's the standard that we were using in this environment. It could be whatever you'd like. It looks like it's already done it now. And now it's on to testing. So I asked it to test, given that it's standard MCP, just use HTTP and do a list tools, do an invoke tool on any of the available tools. And so now it's got the gateway that's API, the API is now agent ready. Now it's on to testing. So let's see what happens here. So it writes a little code to try to test it out. Of course, it's going to be successful, no problem. You'll see in a moment here, it's going to list the tools. First, it's getting an access key from the authorizer. You've got to do a secure invocation here using the MCP protocol. And voila. There's all of the tools automatically coming back as MCP, even though we started with just a REST API. So it's done that mapping, it's got it live. You can plug that into any agent. And here we tested out invoking a tool. So we did MCP call tool on one of the tools to list customers. It was able to do that. Here it's retrieving the details on a particular order. So we've got all of the basics here of managing orders based on existing APIs, and it's available as MCP now. So then it's creating a simple strands agent, and any of these agent frameworks makes it easy to just plug in an MCP server, so that's what it's doing here. And in less than a minute here, it's going to have a running, see it's actually executing right now. It's actually listing servers, getting listing orders. getting order details. So now the Strands agent's already working. We're only a few minutes into this job here. I still haven't done any work. Kind of nice, I like this. And now what I'd like to do is deploy it in the cloud. It's great on my laptop. I want it in the cloud. I want to be able to hand it to app developers and app builders. And so Kiro says, okay, let me see what it takes. It checks out the commands. It figures out all I need to do is configure and then launch. So it does a configure. Configure sees that it's got your agent. It knows how to just then, at that point, package the code, upload it, and then create a secure endpoint for that agent. So that's what it's doing right now. It's doing the packaging. It's getting it uploaded. It's setting up the endpoint in the cloud. Another 10 seconds or so, that'll be running. Once it's running in the cloud, Kiro says, okay, let me test the agent via the command line. So we'll do an agent core invoke, prove that it works. Here it goes right now. It's doing an invoke. And let's see if that works. Hey, what do you know? It's able to list the customers. You can get the details of a particular order. No problem. It's got session management. It's secure session isolation. It can handle those concurrency at scale. And just to prove that out, I ask it to write a simple client script to prove that you can use it from Python, from Boto 3 remotely. And then I had it write a little load test to spin up a bunch of sessions concurrently and prove that that works as well. So there's a nice little demo of not writing any code, taking an existing API, making it available via gateway, writing an agent, hosting an agent in the cloud, all with the magic and wonder of Agent Core. So let me give you four quick takeaways. One, business value only comes when you're in production. Maybe it's obvious, but there is that big chasm, and you need to address that in order to start getting real value out of these agents. Second, know what your agents are up to. Never put an agent in production if you don't have a good mechanism for observability. You need all of the detail there, and you need an easy way to get access to that, and then find a way to iterate and improve your agents, as well as troubleshoot and debug when things are going wrong. Third, security is not optional. Scale is not optional. You're not building toys, you're building production-ready agents to deliver real value. You've got to have security and scale figured out. And then lastly, don't waste time crawling around in that chasm. Use Agent Core and get a smooth path right over that chasm from POCs into production-ready real business value. So with that, here's some resources. You've got great documentation out there, quick starts, tutorials. We've got workshops, self-service, or you can use our help with those. We've got a pretty robust repo with tutorials as well, examples of integrations, A2A, multiple frameworks. If you're looking to learn more about agentic AI overall, this is a skill builder capability. And then with that, I want to thank you all for coming. Hopefully this is giving you a good idea of how to cross that chasm from POC to real production-ready agents. Thank you.